Hey everybody, this is Mr. Schultz here with you. We're going to take a look at 7.2.4 as our lesson for today. So let's take a look at that. It's really going to be a big thing. It's going to be comparing our sine graph to our cosine graph and just kind of knowing what does each one look like and how are they the same and how are they different. Let's take a look at our first problem here. So our first one says, what do you need to know about the sine or cosine functions to graph them? Talk with your team. Kind of talk with us a lot. You would need to know the amplitude. You need to know the period shift. You would need to know the horizontal shift. You need to know that vertical shift. They also have been calling it the midline. I feel like midline is not as used of a topic. But I'm but both of them work there. Yeah, so just kind of those topics are kind of your key things there. That's what we're going to look at next. So we are going to take a look here, split team into pairs, blah, 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 do all this type of stuff, but you're working by yourself here, so you don't really need to worry about this. So basically, we're going to create a graph. And so I just want you to decide on each of these things. So what will the amplitude be of your graph? No, I'm going to make my amplitude 3. And then go to the next one. How far to the left or the right of the y-axis will your graph begin? In other words, what's the horizontal shift? I don't know. Let's choose a random number. Let's call it pi over, pi over 12. Make it kind of a strange one there. How about the next one? How will the x or y, how much above and below the x-axis will your graph be? What's the midline? Let's shift it down for some reason. Let's shift it down by 2. What will the period of your function be? Let's try to make it pi length, just to make it a little bit different than our standard 2 pi. And then what will the orientation? This is kind of a new word here. And I didn't mention it on the last one because we hadn't really got there yet. But you've got sine or cosine. Will it be the same or will it be flipped? So multiple things here. It could be, sine graph typically looks like that. But what if it's just flipped? What if it's the opposite? So that's what they mean, by flipped. And then we've talked about what does that compare to? I should probably graph some lines here so you can kind of tell a little bit more that these are sine graphs. It'd be something like that versus the cosine graph. It starts up and goes down like that. But if it's flipped, then you'd start down and go up like that. So let's have it be a sine graph, just straight up sine graph. And now that you got all that, we're gonna write the equation, but I'm not gonna show you that yet, and I will show you why. Okay, so the reason why I didn't show you the equation, because now in theory you would have been trading with somebody. So pretend that you just traded with me, and I want you to now take my line. These were all the parameters. My amplitude was 3. The horizontal shift was pi over 12. The vertical line or the vertical shift or the midline is at -2. The period is at pi, and the orientation is sine of x, just normal sine of x. So write that equation. Take a second, check that out, and then I'll show you what that equation is. Okay, so coming back here, so I'm going to have a sine of x, so I'm just going to give myself some space here to work around that. Whoops. Sine of x, okay? Well, amplitude, that was 3, so that goes out front. That goes in that a value. My horizontal shift, I'm going to do my next one. It's a positive number, so I need it to be negative here. So that's going to be that. And I want to make sure to put that parenthesis around there. That vertical line there, that's going to be my pink here. Or, excuse me, I was going to do pink. Pink there. Well, that's going to be down 2, so that's that k value there. My period is pi, which remember that the standard period is 2 pi, so I need to go twice as fast to make that equal pi. So I need this to be 2 here. And then my orientation was just normal sine of x, which I kind of already went with there. Here would be your equation for my line that I just did there. All right, so here's a question why I didn't go into cosine graphs. So it says, when you look at a graph and prepare to write an equation for it, you think it matters whether you choose sine or cosine? Hint, hint, yes it does. Which do you think will work best? Your team finds at least 4 different equations for the graph at right. Prepare your equations from there. So when I look at this graph here, let's just take a look at some of the easy things to grab first. So first, the amplitude, I notice it's not going up to 1, it's going up to 2. So I know that my amplitude is going to be 2. It looks like we've been using a sine graph, which always starts here, and so it's been shifted. But if I also look at this and I go here, okay, the period is 2 pi. So it's a normal looking 2 pi, 2 pi for the period is going to kind of put a double thing there. Let's do that. The period is going to be its normal 2 pi. Okay, that's kind of interesting. So there's kind of that shift. If I look at the center line or the vertical, that K value, that midline, what else have we called it? We've called it the midline, the period, and then the vertical shift. That's all happening at y equals 0. So there's actually not a ton happening here. But I do notice that it is inverse because it seems to be going down first. It starts from the bottom, or if you're going from here, then maybe it's shifted. This is where sine and cosine makes a difference. So let's force ourselves to write this in terms of sine. If it's in terms of sine, well, then sine normally starts here. That means that this is shifted. If this is pi, then it's shifted by about 1/4 pi. It's got a horizontal shift of pi over 2. Because, see, this is my pi, and it's halfway to there. So that means that I had to take this point and move it half a pi over there for my sine graph to start kind of normally and go there. I just need to shift it ahead by about 1/4 there. Excuse me, not by 1/2. So my sine graph then, I'm going to take my amplitude. I'm going to say that's 2, so y equals my amplitude. And then I've got my sine graph, and it's going to have my x minus pi over 2 because it needs to shift. Let's see. I actually need this to be plus because I'm kind of shifting it back. If I shifted it forward, I'd be starting from here. If I shift it back, now I'm starting from down there. I'm starting with that negative value in the x. If I think about that in terms of my unit circle. So normally we would start right here, and at here cosine is 1 and sine is 0. But I need this to start at the negative value, and of course this is at an amplitude of 2, so it'd be at positive, positive 2 and 0. So then I'm trying to start it right back here, which would then end up being with a negative, with a 0 for my cosine and a negative 2 for my sine, which is right where I'm starting there at negative 2. And so I actually need to shift this backwards. I'm going back on the unit circle by a 1/2 pi, or half pi radians. So if I'm going backwards, it needs to be the opposite. So I'm going to add pi over 2 so that I'm shifting this graph and I'm starting back here, and then as it goes up here, it'll go to 0, which is exactly what we see, and then it'll increase. It'll be in the positive realm. It'll stay all positive, and then right when it hits here, it's going to go back to negative, just like we see right down there. So kind of jumping back and forth and thinking about these things in terms of that unit circle can sometimes help you to visualize what's happening in the graph, especially with those horizontal shifts. It can be easy to get caught there. But now here is a whole thing that I think makes this a lot easier. If we look at this, we can also think about this in terms of, hey, we don't have to write it as just a sine. There's another graph. There's a cosine graph. Well, that's going to have the same amplitude, so I'll just plug that in. But notice that the cosine graph starts right away at that 2. So now I don't have to think in horizontal shifts. I just need to think, oh, it was supposed to start at positive 2. Well, what if I started in with the opposite of that? Well, I could just make it the opposite of x, and now it's going to just invert that graph, and there we go. There's our second graph. So depending on which one you're going for, you can sometimes make your life easier by not having to worry about a horizontal shift. You could just start with a cosine graph then to get yourself going. Or maybe the horizontal shift is like totally cool to you and this cosine thing kind of throws it off. You can live in that horizontal shift land, but know that these two graphs do end up making the exact same equation. Now, it did ask us for 4 different. What you could do is kind of a cheater thing here, is basically just like here. So on the cosine, I said start with the opposite of it. You could have also started your cosine back here, and then had it go this way until it goes positive. So then you just have to start here, but instead you go 2 cosine x with a horizontal shift backwards, so that you're starting back here of pi over, or in this case, just pi, because you need that full 180. You could also do it like this to be the same thing. You could add that pi because you're kind of halfway. You can either add it or subtract it. It doesn't matter if you go this way around and then start here, or if you go this way around and start there, because they're both going to end you at that same point. So there's 1, 2, 3, 4 of them. If you want to see another sine graph, you could do a similar type of thing, but just maybe shift it through a whole cycle. So end up calling it, what would this be, 5 pi over 2, which is equal to the idea of like 2 pi plus 1/2 pi. So this 2 pi just like moves it through the cycle once. So the short answer is this: there are tons of different ways to write the same graph when you've got something that's just got a repeating pattern. And so just, I think that the key topic here is being aware, hey, when's it going to make my life easier to use sine? When's it going to make my life easier to use cosine? Generally speaking, if you're starting with something that's starting at 0, you want to use sine because that's where sine starts. If you're starting with something that starts at a top or bottom of your graph, generally that's going to be easier than to use cosine because that's where cosine starts. Now, sometimes you will start a graph that'll just be like halfway up, and then it's this kind of dealer's choice. So you could go kind of either route there, whichever one makes more sense to you. Okay, that was a long explanation, but it's a pretty important topic there. So let's see what's on the next page. Okay, so this problem is basically trying to put everything all together here into words. So Brianna's mom's watching her play at the park. She's riding a merry-go-round, which is a thing that goes around and round like this, right? Hey, guess what? That's kind of like a unit circle. Hint, hint, nudge, nudge. We're going to have a cyclical thing here. So at half a second, Brianna is the furthest away. She's 26 feet away. When the stopwatch reads 4.2 seconds, she is the closest, 12 feet away. Find the cyclical equation that models the distance here, okay? So if we think about this in terms of just like a graph here, so I'm going to make a graph, and I'm going to go down here. So the closest she gets is 12 feet away. The furthest she gets is 26 feet away. So at half a second, let's see, let's go what? 1, 2, 3, 4. So at half a second, she's at that 26 there. And then at 4.2, which we'll call that, I don't know, roughly here, she's going to be the closest at 12. So I'm assuming that there's going to be this cycle because because at this point, if Brianna's mom is standing here and she's the furthest away right there, then when she goes around this merry-go-round, now she's the closest. Well, eventually, in a few seconds later, she's going to be back at that furthest point away. So eventually, she's going to be back, which I've got my drawing in the way here to make this actually go to scale. But at some point, she's going to get back up to here. So I see that this is then that's going to make my full cycle right there. I'm going to go down here, and then we're going to go back up here, which isn't quite to scale because this drawing is in the way. It would look probably something more like, I don't know, this-ish roughly. So we've got this kind of full period cycle now that is happening. It's starting at that 0.5 seconds, ending at 4.2, but then it needs to go another one of these distances to get over here. Well, this part of here, this is 3.7 seconds. So I need another 3.7 seconds. And guess what we just learned? 7.4 seconds. That's now my period. That's what's taking up the full cycle distance to go from here to here. Okay, so we just learned something, and it's probably one of the trickier things, which is the period. Okay, now let's start thinking about our other things. We've got our amplitude. Well, that feels like that's gonna be annoying for right now. Let's see if we can find our vertical, or where our midline is going to be. And this is where the midline terminology is probably a little bit more helpful. So the midline just gonna be what's halfway between 26 and 12. So that full distance there is 14. So I need half of it. So it needs to be down about 7, needs to be up about 7, which means it's going to be at 19. So my midline is going to be at y equals 19. This is going to be my midline going through this graph here. Okay, so I've got a midline, and then from here, now that I've got this, hey, I know this is growing by 7. Well, that's now my amplitude. My amplitude is 7. Okay, so now we're starting to get someplace. The very last thing, though, is we have this annoying 0.5 seconds to account for. We've got this 0.5 second shift. Oh, and I guess we didn't truly find our period because our period is happening over 7.4 seconds. So let's take a look at that. So the period we know is normally 2 pi. Let me just write this someplace else here because this is just kind of all over the place. So the period is normally 2 pi, but we know that it's not happening over 2 pi, it's happening over 7.4 seconds. So this full length happens, it's just split over these 7.4 seconds here. So that's effectively my B value there. Okay, well now we're starting to get really close here. So far, what we have is this. We have y equals my amplitude, which is 7, times by my sine of x, but I've got a B value there, so I'm going to go with my B value of 2 pi over 7.4. I've got x. I know there's a shift. I don't exactly know what that's like yet, and that's my last thing to figure out. And my last thing is my vertical change here is going to be plus 19. So my last thing to figure out is how am I going to address this shift here? What can I do to address this shift? Let's take a look at that. So now here's a great example of, okay, my sine graph, remember, we say that normally starts here and increases. So I'd have to go almost a full period back, or I would have to go a little bit more than a half period back to find that. Well, here I'm pretty close. This is just a half second here to being at the top. This is actually where I would probably switch this to be a cosine graph, because now I just need to account for this half second that's happening to get me to the top of that graph. So I'm going to use that. I'm going to use a cosine graph instead of a sine graph, because it's just it feels like it's going to be a little bit easier to me to handle. Okay, so I'm skipping this one now. And I just need to account for this half second shift that is going to happen to make this go. Well, guess what? It's just a half second. I've got my period and stuff already in there, so I just need to account for that half second shift until I get to the top of my rotation there, which is at 26 feet. And there you go. There is your equation. Now, hopefully that didn't look super easy because it's a little bit weird. This part, not too bad. This part, not too bad. This part, probably a little weird. And then if you figure out the cosine piece, this part isn't too bad as well. So just the finding the period can be kind of the weird part of this. But word problems in general with this can be a little bit tricky, but just break them down, write out your graphs, see where you go from there. Let's take a look at our last one, which is a learning log. So just trying to summarize your learning. When does it make sense to use sine? When does it make sense to use cosine? Generally, I say this. If I'm going to use sine, I want to be starting at 0. If I'm going to be using cosine, I want to start at 1. If it's not starting close to one of those things, then it's kind of your choice. But just know that you can use that to kind of choose some other things there. All right, last the math notes. I think this is a great math notes box because it just summarizes everything we've talked about for last bit. It gives you every single definition that we have gotten from there. So just hit some review and preview, and you should be good to go. Have a good rest of your day. Bye-bye.